this is one of those slides that's kind of better seen on your microscopes or on like complete picture. I have to kind of go piece by piece here. Feel free to let me know if you guys don't need to be seeing that particular structure, because I don't have to listen to it. But I have the general idea what you guys need to see. So what you're looking at right now is the front of your eye where the contact lens goes. What is that?
Cornea.
Cornea. So it looks like a bunch of kind of dense, regular connective tissue looking stuff throughout here. And then you see kind of this this epithelial layer kind of lining it on the anterior, on what would be the superficial anterior surface there. So if I kind of follow that back, and what tunic's that part of again, the cornea?
Fibrous.
The fibrous, right? We get down here, you notice there's something in front, towards the anterior there in front of it. What goes in front of your cornea?
Eyelid.
Your eyelid, right? Also known as the inside is the conjunctiva. You guys have ever had conjunctivitis? Infected right? The mucus tissue. Pink eye is kind of a form of conjunctivitis. And you guys are supposed to let me know if you get pink eye, right? So right here, you start to see the vascular tunic. That's a little bit of ciliary body that you kind of see poking out back here. Sometimes you see bigger patches of ciliary body, but you see how dark it is and everything and how it kind of makes all those folds. You might see more as we kind of work our way around here. But I'm actually going to pop back up for a second so you can kind of follow that. So you can kind of follow up from the ciliary body there. You see that we're kind of separate from that's still the cornea out here. We go right behind that. We have this area, which is going to look like kind of, if it ever stopped, you know, we've cut to the side of the eye here. So you're not seeing the pupil in this structure, but you can see it's kind of covering what's behind it there. So you have the lens back here that I'll show you more of in a second, and this is the iris here. The reason you don't see the pupil, obviously the dissection's over from the side, right? If you saw a pupil in here, the iris would look like two fingers kind of coming in. There'd be a gap between them. But since the iris is continuous, it's obviously from the lateral part of the eye. It's a little further out over there.
Since the lens is clear, how does that make a pupil dark?
It's the back of the eye reflection. So again, you see the cornea. We go back. First thing you should run into is the iris, which is usually going to be pretty thin, and then the lens that you can see all the way through there. See a little bit of the striation in the tissue and all that kind of stuff. When you cut the lens so thin, it kind of tears apart like tissue paper. So on some slides, you'll see like these pink torn tissue paper bits. Those are just part of the lens that kind of shredded and tore apart there. And again, you see ciliary body up here towards the top. Some of the slides it's a little bigger, but we are off kind of towards the lateral side of the eye there. So this is no longer the cornea that we're looking at out here. The cornea kind of dies right here, and the cornea becomes what going over the rest of the eye?
Sclera.
The sclera. So you're seeing all this sclera in line there with the
Choroid.
vascular layer, which you're kind of seeing right through here, which should be the choroid, right? And you're starting to see nervous tissue show up there as well, and that's going to be the retina starting to show up. And you're going to see a really well-defined retina as we work our way back here. So now you see a really good retina. You still see choroid, but the choroid kind of separated from, you see the sclera towards the top still, right? All this is the sclera. This is the choroid. The choroid gets pretty beat up for the most part, and that's what allows the retina to kind of pull apart as the slides are being made. So you still see choroid. That's sclera back there. And you see the retina here, and you see all three cell layers pretty well defined. And we'll zoom in. But those cell layers going from the posterior cavity, which would be like down here, that's where the vitreous humor and aqueous humor and all that stuff is. You can see these nuclei that are kind of spread out and look really big. Those are going to be the ganglion. So that's the first layer of cells you run into, kind of moving through the retina here. And then this first thick layer of nuclei, those are going to be the bipolar cells. And then lastly, you have this big thick layer of nuclei that looks like it has little tails coming off. Those are the photoreceptors. Those are the rods and cones. Now I'm going to zoom in on those in a second, but I want to see if we can find the blind spot first. So we're going to go around the eye here. You can still see those, all three of those layers as we kind of move around through here. Sometimes you'll see a fovea, depending on how the slide kind of prepped itself out. That's probably the fovea right there.
Can you explain the maculate?
The macula lutea is just the area surrounding the fovea.
Okay.
So when you look at your model and you see a big ring that has like the fovea pointed to in the middle, the halo around it is the macula.
Okay.
I guess we're too far over to see a blind spot, so no blind spot on this slide. But I will zoom in on the retina, so you guys can see the three cell layers a little bit better here. So again, kind of starting from, here's your posterior cavity, this is where the light's coming in, right? And the light goes past the first two layers of cells. So the first layer of cells, all these big nuclei that are pretty spread out. What were those again? Those are the ganglion. Then the first kind of thick-looking layer of nuclei, that's bipolar cells. And these are the rods and cones in the back, the photoreceptor cells, all of this right here. So the light actually physically passes by these first two and gets absorbed, received by the photoreceptor cells, and then when they send the signal out to the nerve, it's going to basically